All right, so one thing I want to mention with this problem here is that a 90-degree counterclockwise rotation is also the same as a negative 270-degree rotation. That would be a 270-degree clockwise rotation. You would get the same exact point. But notice the mapping notation. It might be a good idea for you to just study that, so that way you know that when you're doing a 90-degree rotation about the origin, that you're doing it correctly. All right, let's move on to the next one. So we're going to start at -3, -1 again for point A. And this time we're doing a 180-degree rotation about the origin. So I'm going to highlight the origin in pink. And again, I'm going to create my box around my center of rotation in point A. And this time I'm going to rotate my box to get 180 degrees. I'm going to rotate it 2 90-degree rotations. So I'm going to highlight the horizontal and vertical line that's attached to my center of rotation, and then those are the lines that just pivot or rotate. So my vertical line of 1 unit long is going to become a horizontal line of 1 unit long, and my horizontal line of 3 units long is now going to become a vertical line of 3 units long. And I can finish off the box. That was just a 90-degree rotation around the origin. I'm now going to take that box and I'm going to focus on the 2 lines that are attached just to my center of rotation. So that's these that I'm highlighting in red. And I'm going to rotate it 1 more 90-degree rotation to make 180. So my horizontal red line of 1 unit long is now going to become a vertical line of 1 unit long. And my vertical line of 3 units long is now going to become a horizontal line of 3 units long. And then I'll just finish off my box. So point A with the 90-degree rotation would be right here. And with the 180-degree rotation, it's going to be right here. So again, point A was at -3, -1. Point A prime is at 3, 1. So what happened, if I write in mapping notation, what happened is my x and y value just became the opposite of the original point. So I have a -x and a -y. Now a 180-degree rotation, whether it's written with a positive 180 or a negative 180, they're the same. So with 180-degree rotations, it does not matter whether you rotate clockwise or counterclockwise. All right, and so my last one, a 270-degree rotation now, that is the same as a -90-degree rotation. So instead of doing 3 90-degree rotations counterclockwise to get 270 degrees, it might just be easier for you to do 1 90-degree rotation clockwise to rotate point A. So let's plot point A, which again is at -3, -1. And my center of rotation I'm going to highlight. And now I'm going to draw my box. And you can feel free to do 3 90-degree counterclockwise rotations to meet that 270-degree requirement. Or what I'm going to do is I'm going to show you the 90-degree clockwise rotation to meet that 270-degree requirement. So highlighting the 2 segments attached to my center of rotation, I'm just now going to pivot those 90 degrees clockwise around the center of rotation. So my horizontal line of 3 units long is now going to become a vertical line of 3 units long. And again, it's still attached to my center of rotation. It just pivoted 90 degrees. And my vertical line that's 1 unit long is now going to become a horizontal line of 1 unit long. And then I'll finish off my box. And so point A now becomes point A prime, which actually lies right here. And that is the ordered pair, -1, +3. So your mapping rule would be that we switched our x and y value around, but your original x value, which is now in the y value place, is the opposite sign of what it looked like. So your mapping rule is y -x. And it might be it might be a good idea to study each of these three mapping rules, so you know that you did your rotations correctly, but also so you can pick out what each of these stand for. So this is a 90-degree rotation, a 180-degree rotation, and a 270-degree rotation. All right, so now I'm going to zoom back out, and we are going to finish the rest of these problems. So for number 11, what happened was my x and y value flipped around, but my y value became the opposite sign. So my rule is -yx, which we learned that that is a rotation of 90 degrees. In my next one, it looks like I am flipping, according to my mapping rule, I'm flipping my y and my x, but this time my x is the one that's becoming the opposite sign. So it becomes a 6, 3, and that's a rotation of 270 degrees. And then for my last one, it looks like what happened was I am going to change this. On yours it is changed, but I'm going to make it a -1, 4. So what happened was my x and y value just flipped to the opposite sign, and that's a rotation of 180 degrees. Great, so looking at number 14, what are the coordinates of Q prime after a 90-degree rotation around the origin? So remember with Q prime, what we do is we make the y value into the opposite of itself, so it's going to become a +2, but then also we are going to flip my x and y around. So it's going to become a 2, 3 as my ordered pair. Great. Number 15. I'm going to rotate this figure 180 degrees about the origin. So proper mapping notation, we can easily do that now because we know what a 180-degree rotation looks like. It looks like making the x and y the opposite. And so then in proper notation, we can do lowercase r, capital R, does not matter. This is a rotation around the origin of 180 degrees. And since there's 3 vertices, that's triangle JKL. And we will get triangle J prime, K prime, L prime. So you can go ahead and draw the original figure if you wish. I'm not going to do that. I know my rule. My rule is that I'm going to just flip my x and y values to the opposite. So if j is at 2, 2, that means j prime is at -2, -2. And if k is at 4, -5, that means k is at -4, +5. And if L is at -1, 6, that means L prime is at 1, -6. And then I can go ahead and just connect the 3 vertices together. to get my triangle. All right, I'm going to zoom out again, and we're going to move on to our last problem, which we've ended both translations and reflections with this problem, so it's only fair that we do rotations as well. All right, so adding my letters here, I have G, M, and H, just like always, and I'm defining that M's the midpoint using rotation rules. So basically, if I rotate G 180 degrees, actually that would be clockwise, so we're going to do negative 180 degrees about point M. That would give me point H, because G is the same distance away from M as H is. So we defined that M is the midpoint in between G and H with this 180 degree rotation. All right, that brings us to the end of rotations. However, we are going to learn how to rotate figures around a different center of rotation that's not the origin in the next lesson.